Find the coordinates for the point that is 5 units away from the point -1, -4, and lies on the line x equals 3. So we could begin by graphing the point -1, -4, and the line x equals 3. The line x equals 3 would be a vertical line where all of the x coordinates are 3. If we were to count horizontally from this point, 1, 2, 3, 4, we can see that on a horizontal line, the closest point would be 4 units. Now we need something that is 5 units away, so it would have to be something that would be on a line, something like this, or maybe something like this, or something similar. We don't know for sure. But we do know that it lies on this line, and therefore the x-coordinate for this point would be 3. And the coordinates for the point that we're starting from would be -1, -4. One way that we could solve this problem would be to use this horizontal line that we've drawn and then draw another line and realize that we have drawn a right triangle. And then we could use the Pythagorean theorem. We know that this distance is 5, that's the hypotenuse, and that this distance is 4, that's one of the legs of the triangle. So we could call this side A, and then use the Pythagorean theorem, a squared plus b squared equals c squared. And then we could just say, all right, a squared plus 4 squared equals 5 squared. So a squared plus 16 equals 25. Subtract 16 from both sides, and we would have a squared equals 9. So now, here's something. If I use the square root property and do the square root on both sides, then I would have to remember that I have to do plus or minus on the right side over here. So I would have a equals plus or minus 3. So, well, what does that mean? Now remember that this a value is this length. And it doesn't appear as though we've drawn this very well. It looks like this length is 2, but it ought to be 3, according to what we've just figured out. So if we redraw this now so that this length is 3, then we would wind up at this point, which would be 3, -1. Now, we also remember that we had a -3 here. So what if we were to go down 3 units? Now, distances can't be negative, but it looks to me like what this is saying is that we could add 3 to the y-coordinate of this dot, which would be 3 minus 4. Or we could subtract 3, and we would wind up with the exact same mirror image of that triangle. So this dot then would be 3, -7. So the answer to this question would be that we have 2 different dots that could work, 3, -1, or 3, -7. Now, I said that there were a couple of ways that we could solve this. The other thing that we could do would be just to use the distance formula. Distance equals the square root of the difference in the x-coordinate squared plus the difference in the y-coordinates squared. And then we could say, all right, here's what I know. I have a dot at -1, -4, and maybe I'll call that x1, y1. And then I have another dot where the x-coordinate is 3, and I don't know what the y-coordinate is, so we'll call it y2. And this 3 would be x2. So we know our distance is 5, so we would have 5 equals the square root of x2 is 3 minus x1 is -1 squared plus, and then we would have y2 minus y1, that would be -4 squared. So 5 would be equal to the square root of, this would be 3 plus 1, that would be 4 squared, that's 16, plus y2 plus 4 squared. Then we could finish solving this out by squaring both sides. And we would have 25 equals 16 plus, and then we could multiply this out. y2 plus 4 squared would be y2 squared plus 8y2 plus 16. And now we have a quadratic that we could solve by subtracting 25 from both sides. And we wind up with y2 squared plus 8y2 plus 7 equals 0. We could factor that. y2 plus 7 times y2 plus 1 equals 0. And then set each of these equal to 0. And we would find that y2 could be equal to -7, or y2 could be equal to -1. And these correspond to the y coordinates that we found using the Pythagorean theorem.